All right, let's talk about expected value. Target number 8. Expected value is kind of fun because you can calculate what you expect to win when you play some random game, probability type game. The realistically expected value just comes down to, can you figure out the probability that you get that win and then multiply it by the value of the win. Sometimes it's money, sometimes it's points, whatever, and that gives you your expected value. And then if you have a list of expected values, you calculate those over and over and over and you add them all up and you get some kind of total expected value down there at the bottom. That's what this one is doing. This one has a Jag Lotto scratch-off game. It costs $1 to play. The payouts are listed here accordingly. Well, here's my probability. My probability of winning $1 is 1 out of 20. So I take that times 1, get an expected value. Then I do 1 out of 40 times 5, get an expected value. Then I do 1 out of 100 times 20, get an expected value. Then I do 1 out of 500 times 100, get an expected value. So I get a list of expected values, add those together, and get my total expected value. One of the things I want to encourage you to do is have good habits when you type fractions in your calculator. So when you go to do this question and you do all these multiply things together, it really is nice to do 1 divided by 20 in parentheses. That way things are keeping, together. So that first one has a 0.05, and then left parenthesis 1 divided by 40. It's a fraction. Group it together like a fraction. And then times 5, boom, that one's 0.125. Then I keep going down my list, and I have a 1 in 100 chance of winning $20. And then I have a 1 in 500 chance of winning $100. And so there are my numbers. So I have to add up 0.2 plus 0.2 plus 0.125 plus, and my first answer was that 0.05. So I need to add that together, add all those together, 0.05, and all my expected values are 0.575, which means that my total expected value is 57.5 cents. So the expected value is 0.575, or you can write it as 58 cents with correct rounding since we're dealing with money. Is it a fair game? The definition of a fair game means the cost to play has to equal the expected value that you just calculated. If the cost to play equals the expected value, we say that it's a fair game. It's fair for both parties. It's for you as a buyer and for them as a seller, it's fair. This case is not fair because it awards me 58 cents on average for every dollar I spend, and I spent $1. So if I spend $1, for it to be fair, I should be winning $1. So it is not fair because the expected value is different from the cost to play. Are the outcomes equally likely? Well, that's a different question. Equally likely means you have an equal likely chance of getting any of the outcomes. Well, when I look at this, these are all different numbers. Those are not equally likely, 1 in 20, 1 in 40, and so on. So the answer to that question is no. Now, if you do happen to look at the spinner that's over here, those are equally likely because they are equally likely that you're going to come up with one of those numbers on the spinner because they're the same size region. So that's the difference there. So some words to know: equally likely has to do with, do you have an equal chance of getting that? Fair game, does the cost to play equal the expected value? And then of course, to calculate your expected value, you do the probability of the win times the amount that you win, and then you add them all together.